All right, so we're going to talk about measurement for a bit. And there are lots of different things we can measure. There's lots of different ways we can measure. And there's a list here that I have for you that is definitely not inclusive, probably not all inclusive rather. And the thing we'll get to the idea of what some of these pieces that are missing, but we're going to go through the most common measurements that we have in mathematics, and keep in mind that there's lots of other measurements that are still mathematical measurements that we don't necessarily think about being measurements sometimes because they kind of fit in with so many other aspects of life. To start with, and the basis for everything is length, and this is something we're going to spend a little bit of time developing here in a moment. But it's the idea that we're finding the distance between 2 points. Width, length, height, depth, all those pieces are actually really interchangeable. When you start talking about the length of something, you're talking about the distance between 2 points. And that'll make a little bit more sense here when we start talking about area and volume. But the thing to remember is like width and height and depth, those are kind of arbitrary definitions. They're all a length. And then we are really just using them in reference to the orientation of a particular object. So their definitions are really very flexible, and we shouldn't put a whole lot of time and energy into trying to figure out which one is which. We're just, like for instance, height is normally the up and down, and width is the side to side, and depth is the front to back. But all of those are a length. So when we talk about any one of those, we're still referring to more or less the same type of measurement. Then we have perimeter, which is the distance around an object. So an idea here would be, and if length is how far is it between two cities, the perimeter would be how much fence do we need to buy to enclose our backyard. And then we have area, which is the space inside a two-dimensional object. When we say two-dimensional, and I probably should put that in quotes a little bit, because when you think about your backyard, what's the area of the backyard? Well, that's not really a two-dimensional object. What you're doing is you're enclosing the surface of the backyard with a fence that is in of itself a third dimension going upward. So when we say the area contained in, that's can be a little bit misleading from that perspective. But we need to remember is that we're talking about the space enclosed by particular boundary lines. So if we're wanting to install new flooring into a particular room of the house, we're still referring to area. That area is simply a two-dimensional space. It's a two-dimensional object, if you will. It's a rectangle or some other shape. Some rooms are definitely not rectangles, especially in older homes. But we are talking about how much space do we need to cover with a floor? How much space do we need to cover with paint? So what does that look like? So, and even with concrete applications, a lot of times it's measured in square footage as opposed to the volume of the concrete. The concrete, of course, is a volume measurement, but a lot of times we measure that in the square footage because the volume is more or less constant for most applications. And then we get to surface area, and of course, area is a surface, right? So when we say surface area, what is that referring to? And we'll talk more in detail about that one. And then we have volume, which is the space inside of a three-dimensional object. So instead of talking about the flooring, we're talking about how much air does a room contain, or how much juice is in that bottle. So the surface area would be, how much ink does it take to cover the surface of the bottle, and the volume is how much milk or how much juice is inside of the bottle. So these are different types of measurements, and we have even more beyond that. Like for instance, these are our just a very quick discussion. We have a few objects here, kind of hard to see, but these are cylinders, and I'm kind of placing them in such a way that's easy to see that these are all the same size. The only thing that's different about them is the type of material they are. So they all have the same length, width, and height, same diameter, all that stuff. They're cylinders. We have steel, copper, brass, copper, and then aluminum. And this one, of course, the aluminum one is the lightest, followed by steel, and then you have brass and copper, which are both pretty heavy little things. And you can always go find those out. But these are pretty heavy, but they are all the same size. So when we measure them, how are we measuring them? So we have these other measurements that we need to talk about as well, one of which is density. And then we have other measurements beyond that, and like say for instance speed or something like that. So when we start talking about measurement, there are lots of measurements we can do. And depending on which measurement we're talking about, we can say these two pieces right here have the same measurement. Or one is vastly bigger than the other. This piece of brass is significantly heavier than this piece of steel. Or even if I want to make it even more extreme, we're talking about these two pieces right here. So we have a piece of brass versus a piece of aluminum. Aluminum is quite light versus the piece of brass, which is quite heavy. They're the exact same size, but they're not the exact same size in terms of their weight. And that weight has to do with their density, which again is another measurement. So going back to this idea of length, how do we measure things? So here I have a ruler, right? So when we start doing measurements, where are these measurements really coming from? Well, we need some type of basis. So we have two systems that we use to measure length in. We have our metric system, which we use inches, meters, and kilometers are the three most common ones. We also have millimeters and nanometers and a whole bunch of others that we use, but centimeters, meters, and kilometers are the ones that most people are most familiar with. And then we have our imperial system or our standard system, however you want to call that, where we use inches. Now, some people want to say, well, if you're going to use inches when you're talking about something of decent size, and centimeters when you're talking about something really small. No, they're actually designed to measure the exact same measurements. If we're talking about this piece of brass here, this piece of brass looks like exactly 2 centimeters, or 2 inches rather. And if I were to measure how many centimeters it is, it looks like it's right around the 5 mark, maybe 5.1 centimeters. Kind of hard to see on the camera there. So what we have here are two different ways, two different bases for how we're going to do this. In a previous video I actually talked about how a foot was more or less defined as being the length of a particular king's foot, right? I forget exactly who it was. And then that was broken up into 12 units for whatever reason, and there was actually a legitimate reason for that. It actually made sense at the time. And then an inch is actually defined, the original definition for an inch was actually 3 pieces of barley placed end to end, and that was the length of an inch. And then it took 36 of those to make up a foot, and that was the basis of the measurement. It was actually based upon barley, which actually makes sense if you're talking about an agricultural system creating a unit of measure. They used barley to measure small pieces. They used your actual foot to measure longer pieces. In the biblical terms, a lot of times cubics were measurement as a form of measurement, which is the length, the distance from your elbow to, I think it was your wrist, which is oddly fairly standardized amongst most adult men. It's pretty close to being within an inch or so for most adult men. So it gave you a really good solid way to measure things. And then you had the metric system. Now the metric system, it's actually based upon a meter, and a meter is based upon how far light will travel in a given time period. And that's how we came up with the metric system, and it's a lot more arbitrary maybe. It takes a lot more science to deal with that. And the real difference is with the metric system, we break everything up into units of 10. There are 10 units between 0 and 1. Compared to with inches, where we actually break this up by fractions, and they both have their usefulnesses. This is marked half an inch, right? And the next, but it's, if we go to the other one, it'd be 1.5. Well, 0.5 and 1/2 are equivalent. But that's kind of where they end, because halfway in between here would be the 1/4 mark, and then you have the 1/8 mark, and the 1/16, and the 1/32 mark, and on down the line, depending on how the accuracy of your ruler. Some rulers will actually go all the way down to 1/64. Although that's extremely difficult to count and measure. So most measurements done in the United States are done according to the standard or the imperial method, and most other countries actually use the metric system. Which one's better? Well, it's actually easier to count in units of 10, so metric is easy from that perspective. But if you grow up with a particular system, a lot of times that system is easier, right? So it's really just a matter of what you get used to. So when we measure inches, how far is it from one location to the other location? So if we're just talking about from point A to point B, we just set up and we say, well, there it is right there. It looks to be about 1-2 inches and whatever this mark is, right? Well, there's the half mark, which means that that would be the quarter mark right there. So 1.25 inches. So this length is 2.25 inches long, okay, which we could also write as 2.25 inches. Which beckons the question, do we have to start at 0? Could we start at 1? Look at that. From 1, it's still 2 inches. From 1 to 3 is a distance of 2 inches. And then you still got a quarter over, right? And this is something that's kind of actually useful when you talk about working with building materials. If you ever use a tape measure, the end of the tape measure actually has play in the tab at the end of the tape measure, and there's actual reasons for that. We won't get into them here, but there are actual legitimate reasons why there's play in the tape measure as opposed to not being play in there. So anytime I measure something and I want accuracy on my tape measure, I actually don't use the tip of the tape measure. I actually start measuring from 1 for that reason. Another thing that's also interesting is that we really could set this up starting the measurement just about anywhere, right? Going from 7 to 9.25. And you start thinking about how, especially young minds, how does this change the way we think? You are practicing, you are forcing the students to practice their subtraction skills, right? But they're also thinking about the measurement. What's the distance between A and B? Well, it's 9.25, but where are you starting? You're starting at 7. So it's 9.25 minus 7, which means that you moved 2.25. So the measurement piece here is kind of very interesting when you start playing around with how you change the starting and ending locations. In any respect, you're still talking about it being a distance, a length, a width, or a height, or a depth, however you're measuring that. And what's also interesting about depth, I don't know if you've really thought about this, but it's a height if it's above ground, it's a depth if it's below ground. But it's also a depth if you're talking about a bookcase. How deep is the bookcase? You're talking about front to back. So underwater is depth, and that's up and down movement. So once again, just pointing out that when we talk about length, these other ways we define length, width, height, depth, all these others, is really very arbitrary. So don't lock yourself into thinking that width has to be side to side. And we're going to look at an example of that here in a minute when we start talking about perimeter and area. All right, be looking for other videos about this. Please reach out with questions and comments as you have them. Take care.